Ever feel like your movie recommendation system just spits few Hollywood flicks no matter what you type? Let's fix that in real time. Stick with me for next few minutes and I'll show you how to build that bot that actually listens and thinks before recommending. I am Shivshankar and today we are building CineGraph, a movie recommendation system that actually understands your preferences and loops intelligently until you find the perfect movie for you. I am not an AI wizard. I am learning this stuff alongside you. We'll figure it out together, line by line, and by the end, you will have a working intelligent bot with which you can play with immediately. We are building a command line interface agent that dynamically adapts to your input, handles multi-step reasoning, and never repeats the same movie twice. Even if you are new to AI, you will see exactly how it works live. Before we start to write a single line of code, let's talk about why we are even using LangGraph instead of a regular LangChain chatbot. Think of it like this. A LangChain chatbot is like a one-shot pancake. You ask for a movie, it gives you an answer, that's it. Reject that recommendation, it repeats itself and forgets what you said earlier. It doesn't remember your preference. LangGraph, on the other hand, is like a kitchen of multiple chefs. Each chef is like a node, and each node has its own specific job. One asks your preferences, another one recommends you a movie, another one checks the feedback given by you, and all of them they talk to each other. The bot actually remembers your preferences and adapts dynamically. And for better understanding, I have created this flowchart. You can see it here. The chatbot actually asks your preferences first and then recommends you a movie and then checks the feedback given by you. If you like the movie, the feedback was positive, then it stops there only. If not, if you said you are not satisfied with the recommended movie, then it will again recommend another movie until you are satisfied. Alright, now that we have seen the big picture, let's start building. First up, we will set up the project structure and install the tools we need so that we can actually bring this bot to life. Alright, enough to talk. Now let's set up our CineGraph project and get ready to code our smart movie agent. I am inside my project directory. I'll open the terminal, and to start with, we will be using poetry for this project. So let me just write poetry new minus minus src. I'll give the project name as CineGraph. You can give anything as per your wish. Now it has created a basic starter template. You can see there is an src folder. Because of this src keyword, we got this src folder. And let's cd into that CineGraph, our project folder. Cd CineGraph. And I will open a new VS Code window inside that directory. And for doing that, I will write code space and dot. We are using poetry to keep our project clean and reproducible. It manages dependencies and virtual environments so you don't end up with a broken Python soup on your machine. And let's just set up the project structure. This is the nodes.py. It will hold the logic for each step of the agent as we have discussed earlier. And state.py. This file will define the structure for tracking the preferences, the movie recommendations, and the responses by the user for those recommendations. And we will also need an app.py. This file will wire all the nodes together inside a workflow. We will also need a cli.py, and this is the file which enables us to use this app through our terminal. We will be able to give our preferences and get the recommendations. And we will also need a config.py file. This is where we will be defining our API keys and we will be configuring our LLM. And let's open this pyproject.toml file. This is actually the heart of our project. Here we need to define the dependencies which we will be needing for our project. I am pasting the dependencies here, guys. You can find the code from the GitHub repository whose link is given in the description. You can see I have pinned all the versions, and let me just modify this Python requires as 3.11. By default, this pyproject.pyml was having 3.12 version of Python, and by tweaking it, I have specified that we will be using Python version 3.11 or greater than that. And you can see I am pinning the dependencies here. By pinning the dependencies, you exactly know what packages work together, and you won't be facing the issues like this thing is working only on my machine, not on the others. You won't be having that excuses, guys. By doing this, the project will work on any machine. And for our project, we will be needing an OpenAI's API key. We will save that OpenAI's API key inside that .env file. It is actually a good practice to save our secrets inside this .env file, guys, because when we push this code to GitHub, whatever secrets we have mentioned here, they won't be leaked into our GitHub repository. I'm saving it. I'll close this .env file and let's configure our LLM now. From .env import load.env OpenAI API key is equal to os.getEnv. We need to import OS also. Import OS. Yeah. .getEnv. We should mention the name of our API key, which we have named as OpenAI's API key. Let's copy it and paste it here. It is saved. And to configure the LLM, we need to import chat OpenAI module from the LangChain package, from LangChain OpenAI import chat OpenAI. And LLM, it is an instance of chat OpenAI. It takes the API key and let's specify the model name. For this project, we will be using GPT-4. And let's give the max tokens as 250. Now let's give the temperature as 0.7 so that it sounds more like a human friend rather than a boring robot. So let's save it. Before we dive into the nodes, let's create a cine state data type. I'm pasting the code here, guys, to save the time. It is the backbone of our project. This is how our bot remembers what the user likes and what it has recommended and what the user is rejecting and what the user is accepting. You can think of CineState as a shared notebook which our agent passes around the nodes. In our agent, there are going to be three nodes. The node 1 will be asking the preferences, and that preferences will be written into this preferences property. And there will be a node 2 which will recommend the user based on their preferences, and those preferences will be saved in this recommended property. And there will be node 3 which will check the feedback given by the user. If our recommendation is accepted by the user, then the node 3 which is checking the feedback will set the accepted to true. If not, it will set the accepted to false and updates the history, which will have the array of the movies which are rejected by the user. This separation makes our nodes clean, reusable and stateless. All the memory is living inside this CineStates class. Now it's time to start coding our nodes. I think I have pasted the code inside this nodes.py. We should be pasting this inside this state.py file. And let's save it. And let's enter nodes.py. There are going to be three nodes that power our CineGraph. These are the building blocks of our multi-step agent. So let's define the first node. It will take the state parameter which is of CineState type, and we need to import this class which we have defined inside a state.py file. So from cinegraph.state import CineState, and this function will be returning us a state, and the state is also of CineState data type. Here we are writing the function return state. This is our node 1, guys. Node 1 doesn't do anything by itself. If you see, we are doing nothing in the node 1. It does nothing by itself. The input comes from the command line interface, but still we are writing this agent because in a multi-state agent, we want clear, modular and reusable steps. Later you can add extra steps here like validating the preferences or logging the analytics, etc. And now let's define our second node. This is where the actual magic happens. We'll name this node recommend movie. It takes the state as input. Its return type is also cine state. And to save the time, I'm pasting the code here, guys. Let's make the indentations properly. And also we need to import the LLM which we have defined inside our config.py from cinegraph.config import LLM. Yeah. Now let me break down the second node. This particular node, it reads the preferences and history inside the passed state. It constructs a GPT for prompt by filling the placeholder value which it will get from here, the genre and the region and the history, everything it will receive from the existing state, and then it invokes the LLM with that constructed prompt. After that, the generated response will be saved inside this REC variable, and that variable is assigned to the recommended property of the state. So it is basically writing the recommended property of the state, which you can see here. The CineState class is having a recommended property, and this second node is exactly overriding that recommended property. Suppose the user prefers a Hollywood movie, action genre, then what happens is the ask preference will collect that input and pass that input into this recommended movie node, and this recommend movie node will set the preferences as action movie in Hollywood, and then a prompt will be constructed based on the genre given as the action, and the region is Hollywood. Since there is no history, this will be empty, and then the LLM will be invoked with this constructed prompt, and the LLM will return a random Hollywood action movie, and that movie details are saved into this REC variable, and then inside the recommended property of this cine state class, this random generated Hollywood action movie will be saved. So the state got updated, and inside this state there is a recommended property inside which we are having the latest LLM generated Hollywood action movie. And after this, we need to define the third node, which is check feedback. Because if the LLM has generated a movie asked by the user, and if the user doesn't like it, he would respond with no, I don't like this movie, then the agent should be checking the feedback. If the user is not satisfied with the response, it should try generating another random Hollywood action movie as per the user's requirement. Suppose if the user is satisfied, he would give a positive response. Yes, I like this movie, I'll watch it. Then the agent can respond politely saying that was a good choice. So checking the feedback is also a crucial step inside this multi-step agent. It will also take the state as input, and it will be returning the cine state as response. Node 3 also doesn't compute anything by itself here. We are including it just to maintain the clear workflow. It's basically a placeholder for feedback processing. In more advanced agents, you might track metrics, log feedbacks, or even trigger other actions. Think of all these nodes as the stations in a factory. Node 1 basically sets the things up, Node 2 does the main work, and Node 3 checks the quality before moving on. Even if some stations just pass the things along, like the Node 1 and Node 3, they ensure that the workflow of the project remains scalable and modular. And there is a question for you guys. How would you expand this node 1 and node 3 so that the bot becomes even more smarter? Drop in the comments. Now, since we have the three nodes ready, it's time to wire them up together inside a single workflow. We will be doing that inside this app.py file. We will also include that loop which will handle the rejected movies, which ensures that the chatbot will not repeat the recommendation which we have rejected. Suppose It has recommended me Interstellar movie. I said I have already watched it. Recommend some other movie. It should not again repeat that Interstellar movie as my recommendation. So we will add that logic also inside this app.py. Okay, the nodes are ready. But right now, they are just disconnected functions floating around. To make them work together, we need to wire them up into a workflow graph. And this is where the LangGraph shows its superpowers, which is something a plain chatbot cannot do cleanly. So for this purpose, let's enter our app.py file. And to save time, I'm pasting the code here, guys. Let me break down what this code actually doing, guys. We are defining a graph. It is a state graph which we have imported from langgraph.graph package. This is a state graph module, and we have also specified that this state graph is going to implement the properties of cine state class, and we named the graph as workflow. And then we have imported these three functions which we have defined in our nodes.py file. And let me just open that nodes.py. We'll place it side by side so that we can see it clearly. We have defined three functions here: ask preferences, recommend movie, and check feedback. And we are importing those three functions into this app.py. These three functions only we are going to use as nodes for this graph. So we are adding the nodes to this graph, workflow.add node. This is the name of the node. We are naming the node as ask preference. We can name it anything. The node actually implements this function, ask preferences function, that we have defined in nodes.py. And then we have added another node to this graph, and we named it recommend. It implements recommend movie function, which we have defined here. And another node we have added, we named it feedback, and that feedback node will execute check feedback function, which we have defined here. So we are done with adding the nodes for our graph. Now it's time to add edges. Edge is nothing but connecting two nodes together. So here basically we tell LangGraph what is the structure and flow of our agent is going to be. So we set the entry point here, workflow.set entry point, and the entry point, the flow of the graph starts from the ask preferences node, guys. So this is the node which asks the preferences of user, and this is the starting point. So we are setting the entry point as ask preferences. This is the name of the node which we have already defined here. And after the agent asked the preferences to the user gives his preferences, and then we defined an edge. This edge connects the ask preferences node to recommend node. That means when the user gives their preferences, the flow should move from ask preferences to recommend movie. That means under the hood, this function should be executed. Recommend movie. So the agent will now recommend a movie, and then it will give as a response to the user. The user will read the response and give some feedback. That feedback could be positive or negative. And to check that feedback, the flow must move from recommend to feedback. This feedback node we have already defined. So to check the feedback, the flow, the agent which was already in the recommend node, now it should move to feedback node. So for this also we are creating another edge. This edge will bridge the recommend node and feedback node. And finally, we are compiling the workflow. We named it Cine app, and we compile it by .compile method. So as we have discussed earlier in the video, this is what is going to be implemented in this graph, guys. This is all we can say. Everything is a graph, and each of the point is a node. There are three nodes: ask preferences, this is the entry point, and recommend movie, this is the second node, and this is the edge we have added here. This is the edge. And after recommend movie, the flow moves to check feedback. That there is another edge we have added from recommend movie to check feedback. And after checking the feedback, if the user is satisfied with the response given by the agent, then the agent will stop. If not, it will loop again. It will again recommend a movie until the user is satisfied with the recommendation by checking the feedback. So basically, in the first step, we have created the nodes, we have named them and gave the functions which are executed because of them. And after that, we have combined them using the edges. And in our particular use case, normally we should create another conditional edge in our graph, which is this one, loop if not accepted, like that. but we have not created because the recommend movie node itself is handling all the logic. It is doing all the heavy lifting. So the way which we have defined this particular flowchart, it is not the exact way we have defined the graph there. We don't have this particular edge defined inside our graph. We only have three edges defined: the entry point and the edge between ask preferences and this particular node and this particular node. These three edges only we have defined. We have not defined this particular edge because the looping logic is already being handled by the recommend movie node. The recommend movie node already uses history and preferences. The retry logic is baked inside this node itself. It is cleaner, simple, and no recursion headaches. That's the entire workflow. Short, sweet. We will build a command line interface using which you can actually chat with this cinegraph. Now it's time to open our cli.py, and guys, let me just paste the code here. I'll explain you what's happening. First of all, we imported the cine app which we have created just now inside this app.py file, this one, cine app, and then we defined a function run cli, and since this is a poetry project, we can use poetry run start to execute this particular file. But first of all, we need to define a script here inside this pyproject.toml file so that this poetry run start actually executes this cli.py file. So we need to write tool.poetry.scripts, because we will be declaring the scripts here. This start is nothing but a script, guys. Start is equal to, so whenever we run poetry run start, this thing will be executed. Guys, I have just realized I have never actually installed these dependencies which I have mentioned in this pyproject.toml file. Rookie mistake. Without installing them, our poetry run start command will not work at all. So let's install these dependencies. Poetry install, because we need a poetry.log file, guys. After these dependencies are installed, we will get a poetry.log file. The dependencies are installed, but we did not get a poetry.log file. Let's see what's happening here.
A few moments later.
And of course, nothing in programming runs in the first attempt. We are getting this lovely error about greenlet. No worries, guys. If you execute poetry update no cache greenlet, this thing, then the error should go. This particular command basically forces the poetry to refresh and rebuild the greenlet package without using any cached junk. And we have also got our poetry.log file. And by the way, you need not stress too much about what greenlet actually is. It's a low-level Python package that deals with lightweight threads and async stuff under the hood. You are not writing the greenlet code yourself. It's just something on which other libraries depend on. Think of it like plumbing. You don't need to understand how PVC pipes are made. You just need to know that you got to tighten a valve whenever it leaks something. Since our dependencies are installed and we got the poetry.log file, let's clear the terminal and execute poetry run start. And before running start, we must save this cli.py file. Control press S, and let me hit poetry run start. Sometimes this kind of errors get resolved by themselves if we install poetry install once again, because just now we have installed this greenlet cache, that stuff. So we need to install this poetry install again so that this error will be gone. This one is module not found error. No module named cinegraph. This cinegraph itself is the module, yes. It's actually there, but it is not able to find that module. So let's install poetry. It's done, and let's clear the terminal. Poetry run start. It says cannot import cine app. Actually, yeah, we did not save this file, guys. We need to save this app.py file. This is where we defined our cine app. This is our graph actually. So if you don't save it, we cannot import that one inside this file. So since we saved it, let's clear the terminal and let's once again Do the poetry run start? And this time, hope this works. God, we got another error. It says no module named LangChain OpenAI. Actually, we are importing this module. I think we imported this one inside our config.py. Yeah, inside this config.py, we have imported chat OpenAI from the package LangChain OpenAI. And since the LangChain version 0.3 has updated, the packages of the LangChain got splitted, guys. So LangChain OpenAI is a separate package. So we need to install it specifically. And if you want to know more information about this LangChain's version 0.3 update, you can check my playlist. The link is in the description. And this playlist was actually started with the first video in which I have already explained what are the changes between LangChain version 0.2 to 0.3. And I have also mentioned this particular thing also, guys, that the packages got split into different modular packages. So let's install LangChain OpenAI. Poetry add LangChain OpenAI. So this one will add the LangChain OpenAI into our poetry pyproject.py file. You can probably see, I guess. There it is. Inside the dependencies, it installed LangChain OpenAI, and it is also mentioned the version. And even in the terminal, we can see the poetry.log file got updated. So let's clear the terminal. God, this time it should work as we expected. Poetry run start. Yeah. So finally, we are seeing the output, guys. Let's open this cli.py file. This particular line which you are seeing, welcome to CineGraph, your movie recommender agent, is printed because of this line. Okay. These two lines are responsible behind this stuff. And then the agent is taking the input from us and saving it inside the genre. Like input, what genre are you in the mood for? Sci-fi, comedy, action, or anything else? We can give our own genre, guys. Let's go with action. It suggested us Mad Max Fury, a movie name, and also gave us a brief description. It gave us the response, and also it is asking us, do you like this recommendation? Yes or no, or type preference. See, this line is printed because of this particular line. It is capturing the input. If we say yes or no, it gets captured into this feedback variable. And there are few if else condition loops which are getting executed here. If we say yes, then it will say great choice, enjoy watching the so and so movie. If not, it will save this movie name, whatever it has recommended, into the scene state. See, scene state we have recommended. It is a list of strings. Okay, what happens under the hood is when we say no, this Mad Max Fury Road, this movie name will get stored into this recommended array. Inside this recommended array, it will go. Whatever movie names are listed inside this recommended array, those movie names will not be repeated again. That means in our upcoming response, it should not again repeat the same recommendation. See, if I say I don't like this again, no, it will suggest me another movie other than Mad Max Fury and John Wick. See, it suggested Die Hard. No matter how many times we do, it will suggest new movies. It will not repeat the same movie. That's the difference between our plain LangChain chatbot and this LangGraph agent. And we will see another magic of this particular thing. Suppose if we type our preference, like I prefer Indian movies, let's see what it gives. See, it gave us Bahubali the beginning. You can see, guys, in the beginning we said action. So whatever movies it recommended, all those movies belong to action genre. And also I said my preference is Indian movies. It narrowed down the preference to Indian action movie. See, Bahubali the beginning is an Indian action epic that you might enjoy. So this movie recommendation agent is working perfectly. So let's say yes and see what it does. Great choice, enjoy watching Bahubali the beginning, so and so. Now let's see what is happening, what's the code behind this cli.py file. Here is our cli.py. See guys, we are initializing the state here. So state is by default having a preferences object which is empty. There is also history, this is a list which is also empty, and we have set accepted to false by default. Now what happening is, from the terminal we are taking a user input, asking them their genre, and that genre will get saved inside the preferences. Okay, inside these preferences, and key will be created named genre, and when we say action will be saved here. So the state is getting updated, and after that, while not state accepted, that means state of accepted is false, which is by default we have set already. This condition is met as true, and this logic will be executed. Whatever is there inside this while loop, that will be executed. And what is inside this while loop? State is equal to cineapp.invoke state. See, inside this state we have preference, and also cineapp is the graph which we have created in the app.py file. See this graph, this is having the nodes. It will start with ask preferences. Ask preferences, it will simply pass that state to this recommend function, which is let's see it here. See, when we invoke the Cine app, the graph gets invoked, and the graph is nothing but the combination of nodes. Nodes are nothing but these three functions which we have created. So what happens is, in the first place, when we pass this state inside this graph, the preferences which is having genre, that genre will go into this ask preferences first. Ask preferences is as it is passing the state inside this recommend movie, and this recommend movie, it is doing all the heavy lifting. It is fetching the prefs as state.get preferences, and preferences we have set here. Initially it was empty, and based on the user's input, it is set to the user's genre, and that genre will be passed inside this prefs. And now if any other preferences are given by the user, all those preferences will be saved inside this variables guys. This genre, this region, this press, etc., everything will be saved here. And then a prompt will be created. After the prompt is created, LLM is getting invoked. LLM is nothing but we have created inside this config.py file, it is GPT-4, and LLM will give us a response based on the constructed prompt, and that prompt will be saved as REC inside this REC variable, and that REC variable we are setting to recommended property of this state. State is already having this property recommended. It is a list of recommended movies. So inside that list, the latest recommended movie will be added. Now what happens? After recommended movie has done its job, this node has completed its job, then the flow moves to check feedback node. This check feedback node will return the response as it is. And once the response is returned, that is what we will get to see inside our terminal. And once we get the response, that response is getting stored inside this state variable. So under the hood of this this particular thing, this much of story is there. So once we get the response inside the state, and the response is actually inside the recommended property of the state guys. So we are accessing the recently recommended movie in this form, state square brackets of recommended. So that's why we are seeing in the terminal that CineGraph suggests Mad Max Fury, so on, etc. Let's try it once again guys. Poetry run start. See, if we say action, now under the hood, the action will go inside this preferences, and the genre will be set to action. And once the action is set, this prompt will be constructed, and the LLM will generate the response based on that prompt. So it has generated Mad Max Fury Road. This response it has generated. Now that response got saved inside the recommended movie list, and after giving us the response, this terminal will ask us, do you like this recommendation? Yes or no, type preferences. I'll say no, I don't like this movie, because we gave the logic if feedback.lower, whatever we write here guys, that will go inside the feedback variable. It is nothing but capturing input. If I say anything other than yes, it will consider that we are not satisfied with the recommendation, so it will again loop back and it will again recommend. So the flow will again repeat. So it again suggested us John Wick is an excellent action movie to watch. And history underscore str, this particular thing will contain all the list of recommended movies. So the LLM will understand that whatever the recommended movies are inside this history.string, we should not recommend those movies. We should recommend other movies than this one. So once it recommended as Mad Max Fury, that will get saved inside this history. And if we are not satisfied with the response, it will again generate a new response, but it will ensure that it is not recommending the movie which is inside this history string. Okay. And suppose if I say yes, if I say y, which is the exact condition which we have coded here, say great choice, enjoy watching John Wick, is an excellent action movie to watch. So we are breaking the loop here. If not, it will continue inside the loop only. The while loop keeps running. Suppose we have our own personal preferences. Let's try running this poetry run start again. And this time we will ask it a narrowed filter to suggest us a movie, an action movie from India. Let's ask it an action movie. It will definitely suggest a random Hollywood movie. It again suggested Mad Max Fury because we have cleared the term so that the history gets cleared. And now I'll give my preference. I prefer Indian movies. Now it should recommend me an Indian action film. See, it has recommended me Bahubali the Conclusion. It is an Indian action film. So in this particular code block, we have hard coded the logic to save the preference and give us the response based on that preference, guys. So this is how our app is working. And there is one thing you might have noticed. I have already said you these particular two nodes, ask preferences and this check feedback. These two nodes are doing nothing. They are just passing the state to their next node, and the CLI itself is handling all the user interaction. But still we need these two nodes, guys, because the workflow has to model the whole conversation. Think of them like a placeholders which actually make the graph flexible in case we want to extend the graph later. So we just built a movie recommendation agent powered by LangGraph. You saw it in action. It asks for your preferences, recommends the movies based on your preferences, adapts when you reject them, keeps track of your choices, all in a clean workflow that a normal chatbot would not even handle nearly as well. So guys, that's all for today. If you learned something from this video, just hit that like button so that YouTube knows that this video didn't waste your time, and also subscribe so that you don't miss my upcoming videos. And thanks for watching.